Okay. So we are on section 9.3. We've got radicals again, square roots. I am going to introduce to you cube roots, which means something times something times something 3 times. That's called a cube root. So, first of all, on this left-hand side, it's also on the board, but I want you to try and do this left-hand side examples, the square roots from memory. So go ahead and fill these in from memory right now. Go ahead, on your paper. Go ahead and start. Thank you. You have like 30 seconds. Okay. So, obviously, square root of 4 is 2. 3. Square root of 16 is 4. 5. I would love to have you memorize these. You're going to see them a lot. And I know you've seen them before. Underneath, I have more for you to write. These are new ones that are commonly used. 2 to the third equals 8, which means the cubed root of 8 equals 2. So, like frontward and backwards basically is what I'm talking about here. Two to the fourth is 16. And that means 2 times 2 times 2 times 2, 4 times, which means the fourth root of 16 is 2. No, I have some threes. All right, then 3 to the third is 27, which means the cube root of 27 is 3. Three to the fourth, that's 81. And then the fourth root of 81 is 3. Four to the third, 4 times 4 times 4 is 64. The cubed root of 64 is 4. We're going to use some of these today. All right. So this is obviously a square root symbol. There is a little 2 here, but the 2 is not written. Nobody writes that little 2. It means square root. So yesterday we did the square root of 25 is the same as 5 times 5, but the square root of 25 is 5. A cubed root is here. That would be like something times something times something. 3 times 3 times 3 makes 27. I could also write it like this. The cubed root of 3 cubed. If I didn't want to write 27, I could write it as an exponent. What happens is when I do a cube root and a cubed, these two things right here cancel out. They're opposites of each other. They undo each other. And my answer would just be 3. And that happens a lot. I'm going to give you a lot of other examples, like the fifth root of 4 to the fifth. These 5s right here undo each other, cancel each other out, and the answer is just a 4. Yeah, we're going to do a few of these today. All right, let's start on the examples. Well, the square root of 25 is just 5. What's the square root of 4? 2. Remember, they come out of the square root. So they're no longer underneath the square root. It comes out. This is just a 10. Not square root of 10, just the whole number 10. On number 2, only the 9 has the square root. The 5 doesn't have anything. So I'm going to do square root of 9 is 3. 5 is already out. So this is going to be 15. Number 3, 20. We did ones like this yesterday. 4 times 5. You have to pick a perfect square. The perfect squares are 4, 9, 16, 25, 36, etc. Square root of 4 times 5. The 2 comes out, but the rad 5 still stays under. 2 radical 5. $24. Give me 24. 4 and 6. Well, the 4 comes out. It would just be 2 rad 6. Yeah, inside the radical has to be a number that couldn't go down anymore. Nothing, no perfect square goes into it. The 2 is not in there because I took it out because the square root of 4 is 2. All right, I already told you about 8. The cubed root of 8 means something times something times something is 8. What times what times what makes 8? 2. So this answer is just 2. The cube root disappears. Another way you could write it would be to make the 8 a 2 to the 3rd power. That means that the 3's would cancel out and you only have a 2. What's the cube root of 64?
4.
What times what makes 64? 4. So we just write 4.
Are we supposed to show the work that this?
Yeah, I'll talk about it when I have to teach. You show your work either way. Number 7. Well, the rad 8 can be broken down. 2 times the square root of 4 times 2. So since 8 could be square rooted, it's not cube root, it's a square root still. I take that 4 out. This 4 becomes a 2. There's a 2 here. What's still underneath? This 2 is still underneath. So 2 times 2, let's go over here. 2 times 2 is 4, and I still had that rad 2 underneath. Eight. Take a break from helping. 4th root of 16. Something times something times something times something. It's the same number makes 16. 2. So you just say 2. Or I could say the 4th root of 2 to the 4th, and then say the 4's opposites cancel each other out. It's just 2. What's the 4th root of 81? So 3 times 3. The 4th root of 81 is 3. Number 10 is where we start having to do a little bit of extra work. Okay. On number 10, actually, before I start number 10, let me do some over here on the side. These are not on your paper. If I do, you should write them down. If I do the cubed root of 5 to the 3rd, what would that equal? The cubed root of 5 cubed. Just 5, yeah. Because the cubed and the 3rd power cancel each other out. Now I'm going to give you one where I have a lot extra in the square root. I'm going to do the cubed root, but I'm going to do 5 to the 5th power. So right now, my cubed root is the smaller number, and this is 5 to the 5th. Answer?
What's the highest power?
You could go into the thousands, 10,000s.
So does that have a limit?
Yeah, but there's no limit. But the calculator couldn't really go that high. It would switch to scientific notation. Okay, this means I have to break up this 5 in here because I really wanted to have a 3rd that I could take out and cancel out. So it's going to look like this. I'm going to break up the 5 into something that has a 3, and then I'm like, well, how many more until I get to 5? So 3 plus what is these 5? I could do 5 squared. So this 3 plus 2 makes the 5. I broke apart this 5 to the 5th because I wanted a 3rd to come out. I wanted a 3 root to come out. In this circumstance, only this and this 5 comes out. But I still have a cubed root of 5 squared inside. So I'm breaking apart a number to make it match my root. Don't worry, I'm going to do 2 more. The 4th root of 6 to the 7th power. I need to break up this 6 to the 7th power so that there's a 4. So for sure, I'm going to do 6 to the 4th. And then how many are left for me to get to 7? Because I want, 4, 5, 6, 7. There's 3 more still. So I'll do 6 cubed. Because these 4s match up, I get to take the 6 out. Still under is this 6 cubed, though. The 4th, 6 times the 4th root of 6 cubed. All right, now that I've given you these three examples, I want to go back to number 10. Because the cubed root of 3 cubed, that matches. Those 3's will cancel. But this 4 to the 4th, I need to break it up into smaller things. Can you stop volunteering? Just stop volunteering. Okay. The 3rd root of 3 cubed, that will eventually come out. And then I'm going to break up the 4. Instead of 4 to the 4th, it's going to be 4 to the 3rd times 4 to the 1st. Because that makes 4, 3 and 1. I'm trying to match my root. If I match my root, I'll get to take it out. This 3 comes out. This 4 comes... I don't have good white out. This 3 comes out. The 4 comes out. But still under there is going to be a third root of 4. So I multiply the 3 times 4 and I get 12. Times the cubed root of 4. Number 10 is lengthy. Number 11. 8 can be rewritten as 2 to the third because 2 to the third is 8. So I'm going to write 2 to the third times 2 to the third instead of 8 times 8. Because the 3's will cancel out. 2 comes out alone, and another 2 comes out alone. The answer is simply 4. Here's a side way of doing it. What if you I really want to do 8 times 8? Fine. What's the cubed root of 64? It's right over here. It's still 4. It's the same answer. You guys, I don't think I finished number 9. 3 times 3 is 9. I don't know. It doesn't look complete. Okay. 12. There's an invisible 2 there. Nobody writes it, but it's a square root. 3. The square root of 3 squared is 3. The square root of 4 squared is 4. That makes 12. So you now have 2 pages. And I want to show you a couple that, let's see. Nothing's too tricky. Maybe like 21. Because the square root of 8 is 2 rad 2 plus 9. You would just leave it. 2 rad 2 plus 9. 6 to the third, you guys didn't know it. It's 216. Minus the square root of 36. Well, the square root of 36 is 6. So 216 minus 6 is 210. The rest I think you can do. Oh, 16 and 17. A lot of kids mess up on this. This means negative 4 times negative 4. That's a positive 16. (17), however, means the negative sign, and then you do 4 squared times 16. So it's just negative 16. So 16 and 17 are different. You also have to finish this page. But these are just the same type of thing. So go to it. I will stop the video.